Okay, so this first one is just what you already know, combining like terms, CLT. So as long as they have the same variable and exponent, you can just add or subtract the coefficient. So if I look at number one, there is, an x squared and a y. So that matches here, x squared and a y. So that means the same variable and exponent. So all we have to do really is subtract the coefficient, which is these two numbers right there. So when I subtract, that turns into a -1, and you keep the exponent and the variable. Okay, so -1 x squared y is the answer here. This is going to be checked. This is going to be your grade for today, is completing the table, the graphic organizer, and then we'll have some practice to go with Alex. So I'm going to do some and then probably have you do a couple on your own as well. All right, when it says subtract 6w from 8w, that's like 8w minus 6w. So they both have the w, so what does this simplify to? 2w. Yep, 2w. So fill that into your table. Now, the product rule is whenever you have the same variable, the same base, so these are your bases, okay? Since those are the same and you're multiplying, you keep that base and you add the exponents. So for the product rule, this is whenever you have the same base, for the same base, you're going to add the exponents. So you can do that mentally. You don't have to show the addition like I'm saying a plus b. Like you don't have to say h2 plus 6. You can just give me the simplified answer. So what is this? H to which power? Yeah, to the 8th power. Now, if it's multiplying numbers, a coefficient, you still have to multiply these two numbers in front of the variable together and then add your exponents. So you're still doing multiplication like you normally do. This is saying -2 times 7, so -14. Then I go to the next variable. Its base was a, and that would be to the 5th power because we're adding the 2 and the 3. Then you go to the next variable, b, and then this is b times b. So this would be b squared, yes. What's the problem? Wherever we have an open seat. Mm-hmm. For the power rule, this is when you're going to need to see parentheses. You're going to have a base, a variable, with an exponent raised to another exponent. So this exponent should be outside the parentheses here. Whenever you have a power to a power, you keep the same base, the x, and now you multiply the two exponents together. So this can also be simplified as x to the ab. So the power rule is used whenever you raise a power to a power. And that means you're going to multiply the exponents. So if I have x to the 2nd power, now raised to a power of 3, this gets simplified as x to what power? 6. Yeah, to the 6th power, because you multiply the 2 times the 3. Now, I'm going to circle this one. Whenever you have a power raised to a power that has a coefficient, you have to distribute that power to each term. So this 2 is going to, this exponent is going to this base of a -2, and it's also going to the 5. So I'm just going to rewrite this. This is saying -2, now with the power 2, and m with the power of 10. Because I said 2 times 5. Oh, okay. Sorry, I'm going to fix my distributing. Now, it turns into a positive 4, yes. When you raise that, so I went here and here, right? So, and then I'm still doing m times m to the third power, okay? Yeah, so when I do a negative 2 to the second power, that turns into a positive 4. Then I look at my m right here to the 10th power and m to the third power. When I'm multiplying, what do you do to the exponents? You add them. So I'm saying 10 plus this 3 would make the m to the 13th power. And that's the final answer. So your quotient rule, this is basically when we're dividing. Whenever we're dividing, you're going to subtract the exponents, as long as they have the same variable base. So I know this is saying x to the a power divided by x to the b. This is really just saying keep that variable x and say a minus b. That's the rule. Now, on number 1 here, for the coefficient for just these numbers, that number, you just do that like you normally do any fraction. It's like saying 27 over 42, or 27 divided by 42. This would reduce, okay? So you can use your calculator to reduce it, but you're going to simplify this fraction. I probably should write reduce. Huh? Did you say 9 over 14? Yeah, okay. That's reduced. All right. 9 over 14. Now you go to the variables x, right? And this is saying 5 on top. And if there's no number, it's an invisible 1. So now we're saying 5 minus 1. So that would be x to the 4th. And that would be our simplified answer. Now, number 2, you have to raise the power first. You're distributing that 2. So that's y to the 4th power over y to the 4th power. Well, this turns into y to the power of 0, because 4 minus 4 is 0. Anything to the 0 power is just 1. You could, if you want to, because they have the same exponent, just cancel. And if you cancel, it still is going to come out to be 1. All right, negative exponent rule. You cannot keep exponents as a negative. So what you have to do is flip and change to positive exponent. Okay, so when I mean flip, it's taking a reciprocal. If we don't have a fraction, you just change that to a fraction, a number over 1. So add that a to a negative 1 over 1. So we're just going to flip this, meaning I'm moving this to the bottom and the 1 to the top. So this now becomes 1 over x to now a positive a. And this is our rule. Okay. So what we do here is only do that for the negative exponents. Okay, this x to the negative 2 is like over 1. So you're going to keep the negative 5, then times that to 1 over x now to the positive 2. Well, this is saying basically negative 5 over 1. So it's just top times top, bottom times bottom. So the final answer is the negative 5 is on top now, and x over 2, or x to the second power, excuse me, is on the bottom now. And it's positive. All right, so We're going to do the quotient rule first. You're going to simplify 4 over 8. That turns into 1/2. I'm just going to change the color, guys, so you don't get confused. All right, so this turns into 1/2. All right, then I'm going to subtract. K to the second power minus k to the fifth power turns in k to the negative 3 power. I cannot keep negative exponents. So we put this over 1 and flip it. So I have 1/2 and 1 over k to now to the positive third power. And this becomes 1 over 2k to the third. All right, exponent rule here, or zero rule, okay? Any base to the 0 power always equals just positive 1. So any number to the 0 power is 1. So 7x to the 0 power, this part right here turns into 7 times 1, which is just 7. We're going to raise this power to a power. So that becomes w to the 8th power over w to the 8th power, which is w to the 0 power, which is just 1. All right, flip it over because you're going to do your extra examples on the back. And I've just realized I don't have it on the screen, so let me turn it on here. Let me fix this. All right. Different problem. Oh, here it is. Hey, yeah, where is this thing? There it is.
I mean, they're just finding your first five. I've actually had no problem. Yeah.
Oh, here it is.
This song. When you do that, like, why can't you get the money? This is song. This is song like right here. You're good song. I can tell you it's smoking or something. No, it's the other one. I could tell like a few seconds ago. Bro, that's not it.
Ah, dang it.
Back in the day, they didn't know. It's like when you're She's definitely doing it in the winter.
No, I do that all the time when I'm getting up.
There's simple. Well, I'm on. There's symbols like that.
Is that what I'm showing my mom when I get so much. It's better than going
All right, there we go. Okay, yes, no, these are the ones you're doing right now on the back of the green paper.
Are we allowed to do one on notebook paper?
No, it needs to be on the back of the green paper. You're gonna turn in the green paper before you leave today. You can write just the answer if you can do it mentally, because I didn't give you. There's only one variable at the end, so I gave you all numbers first.
Oh, so
Just put the answer down. Yeah.
that's a time. It would be. Just not yeah. Well, second one.
Yeah.
Together at that ABC game. So good.
Oh, Lord.
I'm trying to remember my ABC.
Does anyone still need C and D?
Oh, that's all.
Yes.
I have them. I have them.
Okay, what's all of it? What?
J.
Maybe if y'all was paying attention.
I have a question. For A, is it 224?
Yeah, that's what I thought.
224? No, you add.
You add?
You add. It's 2 to the 11th. When it's multiplying, you add. Look, I'll put it back up. When you multiply, you add the exponents. Yeah. So you're gonna write 2 to the 11th power.
That's what I got.
They don't change.
Okay, so can I show the last? There it is.
Can you just go back up now? In this instance, yes. Do not even look at these. You have to look at these two. Oh no.
Okay, nice.
What do you need, Tristan?
Can you scroll up? Wait, they're gonna keep it two.
To where?
See?
Can you go to B?
But I'm saying like why is it's not right. I got to use the power of more. Nobody.
What's up?
I'm hoping it's better. Hey, you know what I got? Hey, you want to oh, The Last of Us. And that's the part. I mean, I already own it, so it's gonna be like $10. I wouldn't buy it. Like 4. Yeah, I wouldn't buy it.
Said, I would have.
I don't know why.
Nah.
Exactly.
And he was like, don't talk to me. That's why.
I know.
I'm never.
You would have been given 2.5 million. I don't know that. That's long. You can just don't want to do it. If you don't really be angry like that, it's all right. But then it's like a slideshow. You went broke. You see, it was barely getting me like, yeah, I was good. Bro, you got one video that has 2.4 million. And then you even have, like, how many likes that? 60,000.
Do we have to do the challenge?
Wait, did you? Oh, did you do a couple of songs? I don't have it. Oh, you got it.